Hey guys, welcome to this new tutorial. So I'm gonna start this new series in which I'm gonna merge the Grasshopper series with the Rhino script series, and we're gonna start looking at how to write Python script within Grasshopper. I just updated my Grasshopper and my Rhino 5, and it seems to be working very well. I'm very happy with the implementation of Rhino and Python. So I'm going to be showing you how to do this script. I just prepared it just to make sure that we can actually go through it. It's a script here. It's not too long. It's quite short actually, but we're using kind of some of the functionality that if you start scripting in Grasshopper, it allows you to do recursion and fractals and things like that, and iterative processes, right? So I'm going to be showing you how to do this script. There is a fractal, a classic Koch curve. So we're just have some control here of the height and the basically the parametrics of the fractal, and then the amount of iteration that you want to do. Like if you want to go 3 iterations, and this should have like a shape, like let's do the proper values of this. So this should be like that. So maybe you know this curve. Yeah, it's a famous fractal, the Koch curve, and we're gonna learn how to do that in Python, right? So if you're interested, just follow along. We have all the parametrics, and you can play with the design of it. And it really starts opening you up like the idea of fractals and recursion within Grasshopper. So let's get started with that. So I'm gonna start from scratch. I'm gonna leave this as a kind of a reminder. So I'm going to start creating 2 points, which is the only inputs that I have here. You can see that if I move this point here, my fractal gets recalculated. So it's all vectorial. It should work pretty well in every direction, right? So I'm going to just leave that into 1 iteration just for now. And I'm going to start with those 2 new points, right? So if you're new to Grasshopper and Rhino, Python, and just start seeing some of the other tutorials, because and I'm assuming that you can just Google how to install Python for Grasshopper, right? Which is going to be this new component. So that's a plugin that you can find in the website Food for Rhino. And we're going to just drag that component here, and that's the way it comes. And I'm going to drag 2 points. Just copy those, right? So I'm gonna go and set 1 point, that's 1. Set 1 point, that's the other, right? So what are we gonna need here is just basically connect these points. Let's rename some of these variables. So this is gonna be pt1, and this is gonna be pt2, right? And the moment I connect them, we can go and open the editor. If you want to check this, we could say print hello world, and that should work pretty well, right? So that's, you know, our Python script is running. We could say that the result A equals x, sorry, pt1 plus pt2, right? So vector math in Python could be done this way, but we have a problem here. We should be able to get a point result out of this, but we have a problem. Like, we have to just hint Rhino and tell him we are going to be using, let me make sure that you're seeing that, we are using vector, right? So let's do that for both points. And you see we basically have the end result, right? So A, it's the addition of those 2, right? So that's working. We're getting a result out of it. Let's start doing some vector math. And again, if you're new to vector math, I have some tutorials on Grasshopper already explaining some of that. So I'm hoping that we can actually just continue with what we've learned, right? So I'm gonna make a comment here, right? I'm gonna define my first point. Actually, let's start being a bit organized and let's describe this as a function. So I'm gonna describe this function we call Koch, right? And it's gonna use two arguments. It's gonna use v1 or yeah, let's call it v1 and v2, right? These are gonna be the two vertices or two vectors that you need to provide in order to create this function, right? So from here we're gonna create p1. That's gonna be our new point, the new point that we're gonna create out of this function. And this is gonna start by saying v2 minus v1, right? And we also need to calculate the distance and things like that. So let's bring here import script syntax as rs, right? So we want to be able to use some of the commands from Rhino. So let's also make a variable called distance. That's going to be rs.distance between v1 and v2, right? So we have the distance and we have a vector of subtraction, so we're calculating the vector between this and that, right? And then p1 we could say equals rs dot vector normalize. So we're gonna start doing some operations to this vector unitize, sorry. So and p1 times equals distance divided by 2, right? So what I'm doing here is just calculating the midpoint, right? I'm calculating the distance, then the vector between those two, unitizing that vector. I think that I need that over there. And I need actually p1 there, yes. So let's see, yeah, that seems to be working fine. So I could say A, and then let's try, just for now, return p1, right? So A equals p1. We have a problem, p1 is not defined. Sorry, so A equals Koch pt1 comma pt2. Right, so I'm calling the function here and I'm defining that my outcome A is the result of the function, right? So the function is calculating the midpoint, and the midpoint is this function Koch. So that should be the midpoint between those 2 points. Let's see. It doesn't seem to be working. Let's find out what problem do we have here. Right, so I need to add to this point, so p1 plus equals v1. Let's try it now. There we go. So whatever I put it, this point should be always the midpoint between those two, right? So so I basically create the vector, normalize it, and then divide it by 2, and then I bring it back to the central position, right? So that's all good. We're gonna comment out this result, and basically we need to create 3 points: one here, and one in the middle that's gonna be elevated. So we're gonna create p1, p2, and p3, right? So this part is gonna be the same, and we can create this 2 and 3 times. So this time it's going to be called v2. So let's unitize it. Distance divided by 2, and this is going to be 3. And then we can say return an array of p1, comma p2, comma p3, right? So if I do Koch, now it should return a series of points. Let's test it. We are having a problem that v3 is not defined, so what we need is p3 here. Cool. So we have, oh, sorry. There we go. So we have 3 points in the same position, but these ratios, we should change them, right? So we want first 1/3, so divided by 3, or we could just use a multiply times 0.3. The second one is gonna be the middle one, that's gonna be up there. So let's multiply it by 0.5 for now. And the third one, it's going to be times 0.66. So we have the 3 points, and again, vectorially, oops, there we go, right? So I'm moving those points around and they're calculated. The second one, we need to add a cross vector here, right? But before we do that, let's use some variables to control the ratios, so we actually can set that up pretty quickly, right? So let's call this one distance 1, or something like scale. Okay, let's just leave distance 1. So we're gonna need 4 distances. Distance 3 and distance 4. So that's good. And I'm gonna create a slider. Because this slider is gonna be between 0 and 1, these are perfect already to just work with the control that we need, right? So let's plug this in to have some control here. And then instead of the ratios, we can say here distance 1, distance 2, and distance, I could say distance 3. Okay, it works. So now we can actually, this is going to be 2, this is going to be 3, right? And the fourth one, it's empty still, because we basically want to determine the height of this guy, right? So let's, how do we add the height here? We can actually say vector cross equals v2 minus v1. So the same thing, cross equals rs dot, we can normalize it again, or sorry, unitize it. And cross equals rs dot vector rotate. So we're gonna do a rotate vector on, so here let's see what we need. We need to provide the vector. We want to cross, comma, angles is gonna be 90, and the degrees is gonna be 0,0,1. That's the axis, sorry. So we're gonna say that this vector, the cross vector, is gonna be the same vector that we're getting between the 2 points. We scale it down, we rotate it in 90 degrees, so now it's facing up, like a perpendicular to this direction. And then we can actually cross times equals distance times distance 4, right? So the fourth value is gonna be the height of the cross vector, and then we have it, so that should be fine, but we need to add it to P2, right? So P2 right now has this position, but if we're gonna add a component in the perpendicular, right? So you see now it's like that. So that works pretty well. So we have all the points, right? We could actually at this point say a polyline. So there we go, polyline. And we're just connecting these points now. If we would want to return all the points, we could say v1, comma, p1, p2, p3, comma, v2, right? Which is the operands. So in that way, we're actually completing the first step of the Koch curve, right? So that's working pretty well. We have the control over the distances. And then we have the height. It's nice to put these controls because you can get the to start mutating the fractal into kind of more of a design output if you want. So yeah, so the first step, it's done. The second step of this is actually making a function that's gonna work with the recursion, right? So this function is done, and let's create another one. So we're gonna say recursive. This one is also gonna take v1, v2, generations, right? So let's start with that. And let's say so because this is gonna be recursive, meaning that it's gonna just loop on itself, we need a way out, right? Like whenever you kind of do a recursive function, you need a way of just stopping, because if not, the computer will like melt out of trying to do an infinite loop, right? So we're gonna say if generations is bigger than 0, do something. And what are you gonna be doing? You're basically gonna call this function Koch between. So we're gonna create a variable that is called new points equals Koch curve of v1, v2, right? So we create the points out of the function that we already had. And what do we do with these points? We need to recall the same function in the function. That's what a recursive function is, right? It's calling itself inside the function. So we're gonna call the function recursive. Now this time with the first point, instead of being v1, it's gonna be the new point. Let's use actually v1, the first point of this operation, right? But then we have to put the generations. It's going to be gens -1, right? So what I'm providing as the 2 points now, it's the first point, so it's going to be the first, but in this, the second point is going to be the first point of the first generation, so it's going to be this guy. So it's going to repeat that operation here, and it's going to, then I will have to ask it to do that for the other side. So let's see if that would work first. So generations -1, it's gonna allow us to keep decreasing the number of generations. So we kind of use this exit, right? So whenever generations it's 0, we don't do it anymore. So instead of calling the function Koch, let's call the function recursive, that is using pt1, pt2. And recursion 2, right? The problem is that our function recursive is not returning anything, right? So even if I test it, I'm pretty sure that the problem is that we're not returning something, right? So we need to say, well, what do you return? Return. Let's add a variable here. We're going to create a list. So all points or all lines, it's going to be an empty array, right? So I want to basically, I'm going to do a list that it's going to be carrying the outputs of such operations. So whenever I start, I provide an empty list, right? That it's going to be a list of lines that it's empty right now. And I provide it, so whenever I calculate this new operation here, the new points, I could say L for line equals rs dot add polyline. And I need to provide the points, right? So the points are going to be 0, so it's just basically going to put all the points from this operation. So this is 1, this is 2, and this is 3. So we have 1, 2, 3, 4, 5, 1, 2, 3, 4, and we need one more. And I think that's it. So we're adding a polyline called L, and we're gonna append that to the list, right? So dot append L. So that means that we are kind of constantly adding the lines that we're creating to the list, and basically what we return is a list with more lines, right? So let's test it. We are still having a problem somewhere. Line 36 here, we maybe need another parenthesis. 2, 3, 4. Unexpected token. Oh, I think we need another bracket like that. And this will take exactly 4 arguments. Yes, that's where. So the new list needs to be provided here. Something else? Right. So let's try this. I think that I found a mistake here. The mistake is that we're getting the new points. This v1 is actually not the point that we should be using. We should be using v0 is the first point, and v1 is the second point. So if we test that, that should work actually. So let's see. And in this case, this is not the right kind of object that we're creating. We're creating lines. And let's see. Oh, we need to add that comment there. Test. There we go. So we're basically creating the line, adding it to the list, and calling that recursive line to the first segment, which is do it again for the first segment, right? So if you imagine this to be done 3 recursions, you have it again for the first segment, right? So that's kind of the logic of it. What we don't want to do, let's say, well, the first thing we want to do is just not only call it for the first segment, but all the other segments, right? So we want to just call it to the second segment, which will be copying this line here between 1 and 2. So that's there, right? So we have it. And then the third one is going to be between 2 and 3. There we got it over there. And then the between 3 and 4. We have it in the last one, right? And again, if we put something like 3 here, I would recommend you not to go too high, because you're gonna definitely kind of start getting problems of speed, or just you might crash if you might run out of memory, right? So let's keep it in 2 as we're kind of working. What I want to get rid of is these kind of middle lines. If you think about it, what it's happening is that the first iteration, it does the line, it adds to the array. The second iteration, it does the line, it adds to the array. So we're kind of, these kind of big lines, we want to get rid of them. So what we could do here is just say, well, if generations equals 1, which is the last generation that would actually work. So we could say append the lines only if you're in generation 1. So you're passing this list of lines along, and only when you get to that last generation you can basically put them in the collection, which is the ones that are going to be output in A. So that seems to work. And obviously the last thing we want to add to this script is a new one here, a new input that is going to be gens. And for this one we're going to use another slider, but this one will be from the type integer, and then we can go to, if we push it, maybe 6. I don't want the computer to crash really, so let's put 3 for now, and then instead of using 2, let's use gens, right? So let's see, there we go. So with this I can control the iterations, I can control the height, I can control the orientation. So you can see I can get a pretty crazy looking fractal. that's just 6 generations, and you could start zooming in, and it has a lot of fine detail. I mean, I'm sure you can just go even further. It seems that it's the performance seems to be pretty good actually. So we could say something like 7. I'm not gonna risk it just not to burn the computer, but you could see like it takes a second and in update, and then just so there's a lot of things you could do with this. You can play with like having different number of iterations in different areas depending on the distance or so on. I mean, and obviously if you're interested in creating curves instead of straight lines, that's certainly something that you can do. But again, I'm just gonna show you the script. Some people ask me to kind of show the scripts at the end of the video, so just gonna show it slowly so you can pause the video at any point. And it's not a long script, it's only that it's a bit tricky to maybe to figure out how to pass the information of the points, but I think that it's been pretty clean, the Koch function and then the recursive function. So yeah, that's it for this one, and we're gonna start kind of doing the tutorials on Python script within Grasshopper, just to have this kind of real-time control over the scripts and seeing them kind of in the viewport. So yeah, I'll see you guys soon.